Hello there folks. Well, what have we got here? We've got a Alba walkie-talkie, the H2 model with a lovely broken antenna. So I've not done this set until the new antenna we ordered arrived. There's no point otherwise doing it. So we'll open it up and we'll see what's inside. Okay, so we've opened it up. I've made sure we've got a chart of what we're adjusting. I've got the full service manual here. It's not the best of photocopies, but we do have that information. Well, it looks quite reasonable inside. So we'll connect it up to the test instruments. And one of the things we would normally do is to go through the antenna socket, which there is on these sets. And unfortunately, I can't find my 3.5mm jack to SO239 adapter. So it's the old crocodile clip leads. Not ideal, but there we go. Just to prove to you we have that switched on. So it's connected to the power supply at 12 volts. These are not 13.8, they are 12. It's very important that it's one of these arrangements where you've got the 10 AA batteries if they're rechargeable, the logic being 10 times 1.2 volts is 12, or 8 1.5 volt throwaway batteries, 8 times 1.5 volts equals 12, in which case you use two dummy batteries, which if you don't have the originals that came with the set 30 years ago, they're readily available. And one of the reasons I say that is the output transistor here is a Motorola MPSU 3.1, I think, seem to recall, and they were unobtainable 30 years ago as far as I was concerned, so always been a bit scary if people go over volt on these. Now there are phase loop instructions in the manual, but my manual is a multiple generation photocopy, so where TL1 is, which is the test point, I don't really know. And if I had one of these come in where I had to adjust the VCO, then I would certainly have to find that out. So we're going to skip the VCO. I have to admit that I've never seen any of the sets using this chassis with the VCO out of lock. I say this is the Alba CBH2. You'll find the same chassis in the Harrier CB2, was it? The H2, and the Harvard H410, I seem to recall. So it's used in 3 identical sets from different names. So where do we start? Well, we'll start with the transmitter. I'm hooked up to the antenna socket, I say through the crocodile clips. That isn't ideal. I should have the 3.5mm adapters. We've got 2 of them in stock. There's 4 test benches here. I can't find them on any of them, so there you go. And crocodile clips to the battery compartment to put in the 12 volts there. So I'm going to go into transmit. So we're on the test set. Okay, there is a snag with this Alba CBH2, and my preliminary checks prove it's actually not transmitting. What's happened is some bright spark has put a preset resistor here. I think it's in place of resistor 4, but I've got such a bad photocopy of the service manual that I can't tell. And luckily I've looked at a scrap chassis that I've got, and there's a 3K3 fixed resistor in there. I think somebody's tried to turn it into variable power or something. Incidentally, I think these are 2 watts. Just quickly look that up and tell you the truth. Yes, it's 2 watts. 1.8 to 2 watts says the service manual. So probably somebody's tried to make it more powerful, I don't know. Anyway, what's happened is I've got a replacement 3K3 resistor, and that's the first thing we're going to do to try and get this thing to work. Okay, so now we've got a new 3K resistor inserted down there. We've probably got a fighting chance of getting it to work. whilst the printed circuit board was out, I noticed some ingress of moisture on the back of the board around the MC3357 IC, so I've dealt with that with the chemical cleaner we have. I'm doing all this before we install that new aerial, because obviously you don't have to go to all the trouble of installing a new antenna in the radio and then discovering that it's actually irreparable. So I'll get the set to work as a chassis before I start messing about like that. Okay then, once I got inside the set, I realised there's some problems. Having hooked it up to the test equipment, I got no transmit, and it's not surprising, but with a broken aerial, the output transistor, which is there, was burnt out. Now I've taken one off a scrap chassis. We don't use second-hand parts. All parts are new here, but we do have scrap chassis because sometimes you have coils and cores from coils that are broken, and that seems to be the only way really to get stuff for 30-year-old sets. But on this occasion, the MPSU31 transistor, which is a Motorola device used in these, I couldn't even obtain these 30 years ago. And occasionally, you know, you see scrap chassis available, and we'll buy them up. And fingers crossed, it's a working device. And in this case, the scrap chassis had a working part. So our first transmit coil is that one there, and that's T6. So I'm now going to go into transmit. We've got 12 volts on the power supply. This radio should do 2 watts. I'm on the 3 watt range, and it is doing 1.5 watts. Anything after over 1.8 watts is acceptable. That's peak, that one. We'll move now to the second transmit one. So we've done T6, T10 is the next one. Fraction more there. And T11 is the third one on transmit. That's brought us up to 1.6 watts. So I'm going to run through those again, just to make sure that that's peak. There we go. And then there's the next one on transmit is T2. Core of T2 is broken. T3. The core of T3 is broken. T4. The core of T6 of T4 is also broken. You know, you get these screwdriver experts, and the point is why we say you can't use screwdrivers on these. They have to be parallel, not wedge shaped, otherwise the cores will break. And the scrap chassis, all the cores are broken too, so you know this is the difficulty. However, it's doing the kind of power it needs to do. I might just be able to coax that one to move. I can. And I'll tell you what, 1.8. Two watts. We've got away with it. You know, what can you do under these circumstances? I can send the set back and say we couldn't tune it up in the proper procedure. The point is it's doing 2 watts, and I'm sure they'll be very pleased at that. Right, move on to getting the frequency spot on. Should be 27.79125. It's 27.79221. As I've said many times before, these drop naturally with age, which tells us it's been fiddled with. 7912. Come on. 129, that'll do nicely. They also have a high-low power setting, and it's through the battery case at the back, which is kind of really silly. I'll just see what it's doing on that. It's doing 600 milliwatts on low power. So the operator has to take some of the batteries out to put it onto low power to save battery life, which is a bit bizarre. Anyway, 2 watts on frequency, and so the next thing we need to do is set the deviation. That's variable resistor 1. This will be novel. All I can do is really the whistle test, and that's well over the top. So again, that's been screwdrivered. It's VR1 is the deviation, and VR1 looks to be that one there. And there we have it, 2.2. Wallow, that's okay. So that sets up the transmitter. So the next video will deal with the receiver.